They laughed when he bought a broken windmill. It now powers his entire farm for free. The windmill arrived on a flatbed truck in the second week of March, 1987. Dented, rust running from the hub down every blade like old blood. 3 of the 6 vanes were bent at angles that made no mechanical sense. The driver didn't bother helping unload it, just unhitched the trailer and left it in the mud at the end of Ray Cutler's Drive, half a mile east of the county road in Comanche County, Oklahoma. Ray was 58 years old, had been farming the same 340 acres since 1963. Wind he had plenty of, money less so. The windmill had been pulling water from a livestock well on the Halstead property 12 miles south before a tornado bent it sideways in the spring of 1985. The Halsteads wanted it gone. They were going to a submersible electric pump. Halstead told Ray the windmill wasn't worth the scrap, charged him $40 for it anyway, which Ray paid in cash from the front pocket of his work shirt. His neighbor to the east, Gerald Pruitt, drove by on his way to the co-op that Tuesday morning. Slowed down, looked at the flatbed, kept driving. The windmill stood 24 feet tall when assembled. Ray knew that from the plate bolted to the base. International Air Motor, 1948, Model 702. The old water pumping type, not the power generating kind. That was the first thing people misunderstood. Ray Cutler wasn't planning to pump water. The farm sat on the western edge of the Wichita Mountains flatland runoff. Comanche County gets an average of 28 inches of rain per year, but it comes in bursts. 6 wet weeks and then nothing. The wind, though, doesn't stop. Hasn't since Ray's father broke ground in 1941. The anemometer Ray mounted on his silo in January of 1986 had logged an average of 14.3 miles per hour across 11 months. Consistent, reliable, free. The power company had been billing Ray $214 a month for the past 3 years. In 1986, the bill hit $287 in July, when he was running irrigation pumps and the grain dryer simultaneously. He'd sat at the kitchen table with that bill for a long time. Didn't say anything about it. Just folded it in half and put it in the drawer with the others. He'd been reading about wind power for 2 years before he bought the Halstead windmill. Not the big commercial turbines they were building out in California and Denmark. Those cost $30,000 apiece. The rural alternative energy publications that came through the mail, the ones with stapled spines and small print, had been covering small-scale conversions since the early 1980s. Ray had a file folder of them. 18 issues. He'd read each one twice. The Air Motor 702 was a drag-type rotor, designed for high torque at low RPM, not designed for electricity. But Ray had spent 2 winters working through the math on his kitchen table, and the math said something different. Gerald Pruitt stopped by on a Wednesday in late March. Said he was looking for a fence stretcher he thought he'd lent Ray 2 years back. He stood in the yard, looking at the windmill laid out in pieces on a tarpaulin. The vanes had been straightened with a heavy press. The hub was disassembled. Bolts sorted into coffee cans by size. Bearings soaking in kerosene. Gerald said he didn't think Ray could make that thing work. Said it plainly, the way men in Comanche County said things. Not unkind, just direct. Ray told him he was probably right. Then went back to work. The nearest wind energy technician was in Lawton, 34 miles north. His name was Dale Wexford. He'd worked on commercial wind installations in the Texas Panhandle and had returned to Lawton in 1984 to start a consulting business. The business had 4 clients. 3 of them were hobby farms with catalog-bought turbines that needed occasional calibration. The 4th was a chicken farmer who'd given up after 8 months. Ray drove to Lawton on a Thursday. He brought his file folder and the measurements from the air motor plate and the 11 months of anemometer readings, spread them on Wexford's desk. Wexford looked at the materials for 12 minutes, Said the air motor wasn't designed for electrical generation. Said the blade pitch was wrong for spinning an alternator fast enough to produce useful voltage. Said the rotor diameter of 8 feet would top out around 180 RPM in a 14-mile wind, and you needed at least 300 RPM for a standard car alternator to charge a battery bank efficiently. Ray asked what it would take to get there. Wexford said it wasn't worth the engineering. Said to buy a proper turbine from a manufacturer. The cheapest viable unit was $4,200 before installation. Ray thanked him. Drove the 34 miles back to Comanche County, stopped at a salvage yard on the edge of Lawton on the way out of town, bought a 1974 Delco 12SI alternator for $18. The problem Wexford identified was real. The air motor blade pitch was designed to catch wind and spin slowly with enormous torque, enough to lift water from 40 feet down in a 10-mile breeze. That same torque profile was useless for generating electricity. You needed speed, not strength. To get speed from a slow-turning rotor, you needed to multiply the rotation, a gear ratio, or a belt drive. Ray had been thinking about belt drives since January. He drove to the implement dealer in Elgin on a Friday morning in April and bought a used flat belt pulley, 3 inches in diameter, salvaged off a line shaft. Cost him $9. The alternator pulley measured 2.4 inches. The ratio between a large pulley on the windmill shaft and a small pulley on the alternator would multiply the rotation. The math worked out to a 5.2 to 1 increase. At 180 RPM from the windmill, the alternator would spin at 936 RPM. Enough. The belt system took 3 weeks to design and 6 days to build. Ray fabricated the mounting bracket himself from 3/16-inch steel plate using a drill press and an angle grinder in his shop. The bracket bolted to the windmill's main frame and held the alternator at the right tension for the belt. He went through 2 belt sizes before finding one that didn't slip under load. The final configuration used a 48-inch B-section V-belt from the Napa store in Lawton. Cost $11. The windmill went up on a Saturday in early May, 1987. Ray and his son Kevin, who'd driven down from Stillwater for the weekend, raised it with a rented crane truck. The tower base was concrete, 2 yards, mixed by hand in Ray's drum mixer. Setting time, 4 days. The electrical connection ran through conduit down the tower leg, across 60 feet of underground cable, into the machine shed. The battery bank was the largest single cost of the project. 8 Trojan T105 deep cycle batteries, bought used from a golf cart dealer in Duncan for $28 apiece. Total, $224. Ray wired them in series parallel to get a 24-volt bank with 450 amp-hours of capacity. He'd read about battery banks in an issue of Alternative Energy Sourcebook from 1984. The issue was dog-eared on the battery page. The inverter was surplus government equipment bought at an auction in Chickasha. Trace engineering model, 1/500 watts. The auction description said it needed a new capacitor. The capacitor cost $7 at an electronic supply house in Oklahoma City. Kevin replaced it on a Sunday afternoon, working from a circuit board diagram Ray had ordered by mail for $3. The total project cost, tallied on a legal pad the week before the windmill went up, $612. Wexford had quoted $4,200 for a catalog turbine. Ray had spent $612 on everything, including the windmill itself. The first day of operation was May 14th, 1987. Wind that morning, 11 miles per hour from the southwest. Not strong. Ray watched the vanes begin turning at 7 in the morning. The belt drive engaged. The alternator started charging. The battery bank voltage meter, which Ray had mounted to a board in the machine shed, read 23.8 volts at startup. By noon, with wind gusting to 16 miles per hour, it read 26.1 volts. The bank was charging. Kevin drove back to Stillwater that evening. Before he left, He stood in the machine shed, looking at the voltage meter for a minute. Didn't say anything, just nodded once. The windmill ran for 6 days before Ray ran into the first problem. The alternator overheated on a windy Tuesday. Comanche County hit 23 miles per hour, sustained for 4 hours. The alternator ran hot enough to trip its internal thermal cutoff. Ray had expected this. He'd read about it. The standard Delco 12SI was designed to run in moving air under a car hood. Mounted stationary on a windmill frame, it had no cooling airflow. He'd already ordered a small 12-volt cooling fan from a surplus catalog. The fan mounted to the alternator housing with 2 hose clamps and ran off the battery bank itself. Problem addressed. Cost $4. The battery bank ran the machine shed lighting, the grain dryer blower motor, which was the single largest electrical load on the farm, and the stock tank heater through the winter. Not the house, not the main irrigation pump, not everything. But the grain dryer and lighting together had been running $85 a month on average through the harvest season. The first utility bill after the windmill went live came in June 1987. The bill was $200. Same as before. The windmill had only been running 3 weeks. Most of May's usage was already on the meter. July's bill was $181. August was $163. By November, with the grain dryer running off the battery bank through the harvest, the bill dropped to $97. Ray kept a ledger in a spiral notebook. Date, wind speed if he checked, voltage reading morning and evening, any maintenance done. He'd been keeping farm ledgers since 1963. This was just another one. The first year's electricity savings totaled $847. The windmill had cost $612 to build, paid for itself before the first anniversary. Gerald Pruitt came by in the fall of 1987 to look at the cattle loading chute Ray was replacing. He stood in the yard for a while. The windmill was turning overhead, belt drive humming. Gerald said he supposed it worked then. Ray said it worked fine. Gerald looked at it for another moment. Didn't say anything else about it. Helped Ray wrestle the new chute panel into position. The second winter was the real test. January 1988 brought ice storms across Comanche County. 3 days of freezing rain in the second week of the month. The windmill blades iced over on the second night. Accumulated enough weight to stall the rotor. Ray had anticipated this from his reading. He'd welded a small oil-filled drum heater onto the hub, housing the previous fall, wired to run automatically below 28 degrees. The heater prevented ice formation on the hub bearings, but the blade icing was a different problem. He did what farmers in Comanche County had always done with ice. He waited for it to melt. It melted on the 4th day. The windmill started turning again. The battery bank, which had been drawing down through 3 days of no generation, was at 22.4 volts when the ice broke loose, still functional. The inverter had been running low-draw loads only, the stock tank heater, the shed lighting, and had managed the deficit without interruption. Ray noted the ice event in his ledger, noted the 3 days of downtime, noted that the battery bank capacity was sufficient to carry the essential loads through the outage. Noted 3 months later that the blade design itself might be improved with a slight pitch modification to shed ice more readily. He didn't make that modification. The math wasn't worth it for a 3-day event that happened once every few winters. He wrote that conclusion down too. By the end of 1988, the windmill had generated enough electricity, measured in utility savings, to cover its own construction cost twice over. Ray kept the ledger entries precise. He didn't estimate. He recorded what the bill was. Then he recorded what it would have been based on the previous 3-year average. The difference was the savings. It wasn't complicated math. He'd been doing farm accounting since 1963. Dale Wexford drove out to the farm in the spring of 1989. He said he'd heard about the project from a county extension agent who'd heard about it from someone at the co-op. He stood in the machine shed for 20 minutes, examined the belt drive assembly, checked the battery bank connections, looked at 2 years of ledger entries Ray spread on the workbench. Wexford didn't apologize for what he'd said in 1987, didn't acknowledge he'd been wrong to dismiss the project. He asked if Ray would be willing to describe the belt drive system in detail. Ray described it, every measurement, every bolt size, the pulley ratios, the belt specification, the alternator modification for cooling, the battery wiring configuration. He talked for 40 minutes. Wexford took notes on a yellow legal pad. 6 months later, Wexford published a technical bulletin through the Oklahoma Energy Extension Service. It described a low-cost wind conversion method for legacy water-pumping windmills. The belt drive configuration was described in detail. Ray Cutler of Comanche County was listed as the source. Ray didn't know about the bulletin until a farmer from Kiowa County called his phone one evening in November 1989. The farmer had read the bulletin, wanted to know if he could come look at the installation. Ray said he was welcome to. 3 farmers visited from Kiowa County that winter, 2 from Tillman County, 1 from as far as Garfield County, which was 90 miles north. They came at different times, brought notebooks, some brought cameras. One brought his teenage son who asked more questions than his father did. Ray answered every question, walked each group through the machine shed, showed the ledger, showed the belt drive, showed the voltage readings. He charged nobody for the information. By 1991, the windmill had run 1,534 days. Ray calculated that number from his ledger, the exact start date, May 14, 1987, and the current date, November 3, 1991. Downtime totaled 11 days across 4 years. 9 of those were planned maintenance. 2 were unplanned, the ice event and a belt replacement in the summer of 1990, when the original B-section belt finally cracked after 3 years of service. The replacement cost $11, same as the original. Cumulative electricity savings through 1991, $4,912. Total project cost, $612. The ratio didn't require a calculator. He added a second battery bank in the summer of 1992. 8 more Trojan T105s, this time bought new. Cost $44 apiece. Total for the expansion, $352. The expanded bank allowed him to connect the well pump for the house, a 1.2 horsepower submersible, to the wind system. That brought the monthly utility bill down to $61 in the summer of 1993. The lowest it had been since the early 1970s. The windmill ran through the 90s. Ray noted in his ledger the years when wind was strong and the years when it was weak, measured in the difference between his projected savings and his actual bills. The 1994 readings were below average. So was 1998. Every other year met or exceeded expectation. The 11-month average of 14.3 miles per hour he'd measured before the installation turned out to be accurate. The Oklahoma wind kept its side of the agreement. Ray Cutler farmed Comanche County until 2007. He was 78 years old when he sold the property to a couple from Lawton who wanted to raise beef cattle and had no interest in wind energy. Ray walked the buyer through the machine shed on the day of closing, showed him the windmill, explained the belt drive and the battery bank and the inverter. The buyer listened politely, said he'd probably disconnect it and go back to straight utility power. Ray said that was his choice to make. The buyer disconnected the inverter in the spring of 2008. The windmill kept turning. The alternator kept charging the battery bank. Nobody connected the bank to anything. The system just ran, unused. A neighbor of the new owner, a man named Carl Duchesne, who'd been farming the adjacent section for 12 years, noticed the windmill still turning in the fall of 2008. He'd known Ray, had seen the ledgers once, years before. He called Ray at his daughter's house in Lawton, where he'd moved after selling the farm. Ray explained what was still connected and what wasn't. Told Duchesne the system was functional. Told him the belt drive needed inspection every spring and the batteries needed water every month, but that was all. Told him exactly which measurements to check. Duchesne talked to the new owner, reached an agreement, reconnected the inverter in November 2008. The system had been running disconnected for 7 months. The battery bank voltage read 25.6 volts on reconnection day. The wind hadn't stopped. The windmill ran on Duchesne's neighbor's property for another 6 years. Duchesne helped with the annual spring inspection starting in 2009. He documented the maintenance process in a spiral notebook of his own, started the same way Ray had started his: date at the top, condition notes, voltage readings morning and evening. Ray Cutler died in March 2013. He was 84. His daughter found the original legal pad with the $612 project cost tallied in his handwriting. Found 26 years of ledger notebooks. Found the Air Motor 702 data plate he'd removed when the tower finally needed replacement in 2004 and kept in a coffee can on his workbench. The windmill itself, or rather the third tower it had run on by then. The original needing replacement in 2004, a second tower installed in 2011, was still operating when Duchesne's neighbor sold the Comanche County property in 2017. The new buyers kept it running. The Delco alternator had been replaced twice. The belt drive design was unchanged from the original. The battery bank had been updated once with newer technology. The total electricity generated over those 30 years, translated into savings at the rate Ray's ledger had measured, came to just over $34,000. The project cost $612. The air motor data plate is still somewhere on that property, probably the machine shed. The wind in Comanche County runs between 12 and 16 miles per hour on most days. Has since 1941. Likely since long before that. Doesn't cost anything.